this polynomial is divided by x minus 3. And we need to find the remainder when this is divided by x minus 3. So we denote this by px. Px is equal to x cube minus 9x square plus 26x minus 24. What is the remainder if px is divided by x minus 3? We know from the remainder theorem that if a polynomial px is divided by x minus a, the remainder is pa. So if px is divided by x minus 3, the remainder should be equal to p3. So let us calculate p3. We substitute 3 in place of x in this expression. X cube becomes equal to 3 cube minus 9x square is 9 into 3 square. 26x is 26 into 3. And we have minus 24. So this is what we have. 3 cube is 27 minus 3 into 3 is 9. 9 into 9 is 81 plus 26 into 3 is 78 minus 24. So let us collect the positive terms together. 27 plus 78 gives us 105. 27 plus 78 is 105. Minus, add the negative terms together. Negative 81 and negative 24 gives us negative 105. So we get 0. So P3 is equal to 0. Or we can say that the remainder of this division is equal to 0. So the remainder when this polynomial is divided by x minus 3 is 0. We know this identity. Dividend is equal to divisor into quotient plus remainder. So let us substitute this in place of dividend. So this polynomial is dividend. Divisor is x minus 3. We don't know the quotient as yet, but the remainder is 0. We have calculated the remainder using the remainder theorem. So the remainder is 0. This can be written as this dividend is equal to x minus 3 into quotient. Now what does it tell us? It says that x minus 3 is a factor of this polynomial because x minus 3 completely divides this polynomial as it leaves remainder 0. So x minus 3 completely divides this polynomial. Hence x minus 3 is a factor of this polynomial. So for any divisor, if we get the remainder as 0, then we can say that that divisor is a factor of the dividend. Now let us generalize this. Dividend is equal to divisor into quotient plus remainder. So we take a general dividend which is px, divisor is x minus a. Say we get the quotient as qx and remainder as r. Now put x is equal to a. So we get pa is equal to a minus a into qa plus r. This is what we have. This a minus a gives us 0. So 0 into qa will be 0. So we get pa is equal to r. This is what we have from the remainder theorem, that if we divide any polynomial by x minus a, we get pa is equal to r. Now if this remainder is 0, that is if we have r which is equal to pa as 0, if we have r is equal to pa as 0, then this part will be 0. So we'll have px is equal to x minus a into qx because r is 0. So px is equal to x minus a into qx. So Px is x minus a into something, or we can say that x minus a is a factor of Px. So if Pa is equal to 0, we can say that x minus a is a factor of Px. Whenever we have Pa 0, x minus a will completely divide Px. That is, x minus a will be a factor of Px. Now for the time being, say we do not know anything about Pa, but we know that x minus a is a factor of Px. So we can write Px as x minus a into something, because x minus a is a factor of Px. We know this. Now what if we substitute a here? Substituting a on both the sides will get Pa equal to 0. So we get Pa equal to 0 by substituting a on both the sides. So this condition holds both ways. If Pa equal to 0, then x minus a is a factor of Px. Also, if x minus a is a factor of Px, we can conclude that Pa is equal to 0. So this condition holds both ways. If any one of these is satisfied, the other will automatically hold. So Pa equal to 0 implies x minus a is a factor of Px. Now for a polynomial Px, if P2 is equal to 0, then a factor of Px will be. Now we have seen that if Pa is equal to 0, then x minus a is a factor of Px. So if Pa is equal to 0, then x minus a is a factor of Px. We have P2 equal to 0. So what should be a factor of Px? Simply write 2 in place of a. So x minus 2 will be a factor of Px if P2 is equal to 0. So we come to the factor theorem. If Pa is equal to 0, then x minus a is a factor of Px. Because if Pa equal to 0, then if we divide Px by x minus a, remainder will be 0, which is what we had from the remainder theorem. So if Pa is 0, x minus a is a factor of Px. Also, if x minus a is a factor of Px, then Pa will be 0. Because as we had seen, if x minus a is a factor of Px, then Px can be written as x minus a into something. And if we substitute a on both the sides, we get Pa as a minus a into something. This becomes 0, so Pa becomes 0. So it holds both ways. Now is x minus 1 a factor of x square minus x minus 2? So is x minus 1 a factor of x square minus x minus 2? We have already studied factor theorem. For x minus a to be a factor of Px, Pa has to be 0. So for x minus 1 to be a factor of Px, P1 has to be 0. So let us calculate P1. P1 is 1 square minus 1 minus 2, which is equal to 1 minus 1 minus 2, which is equal to negative 2. So this is P1. This is not equal to 0. So we can say that x minus 1 is not a factor of Px, because P1 is not equal to 0. So x minus 1 is not a factor of Px. So using the factor theorem, we have said that x minus 1 is not a factor of this expression. But using the factor theorem, we can also say what is a factor of this expression. That is, we can factorize this expression using the factor theorem. So we need to check different values for which px will become 0, and based on that we can find the factors of px. We do it using trial and error. So we have checked for 1. Let us check for -1 now. We check whether p -1 is 0 or not. If it is 0, then we can say that x minus -1 is a factor of px. So let us check p -1. We need to substitute -1 in place of x. We get -1 square minus -1 minus 2. -1 square is 1. Minus -1 gives 1. Minus 2. So we get 0. So p -1 is 0. So if pa is 0, x minus a is a factor. So if p -1 is 0, then x minus -1 should be a factor. That is, x plus 1 should be a factor of px. So we can say that x plus 1 is a factor of px. Now our aim is to factorize px. So x square minus x minus 2 can be written as x plus 1 into something, because x plus 1 is a factor of this. Since we have an x square term here and this is x plus 1, we'll have some more factors here. Now we have x square here. We have x here. We need to have x plus or minus something here in order to get this x square. Because if we have a factor of the form x plus or minus something, then this x into this x will give us x square. X into x will give us x square, which is what we have here. So we need to have a factor of the form x plus minus something. In general, whenever we have an expression in which the first term is x square, that is a quadratic polynomial with coefficient of x square is equal to 1, then we have two factors of the form x plus minus something, so that this x and this x give us x square. What if we have three factors? Say we have a third factor of the form x plus or minus something. Then this x into x into x will give us x cube. But we do not have an x cube term here, so we cannot have a third factor. So we'll just have two factors. Out of these two factors, we have already got one factor, x plus 1. We need the second factor. So let us try some more values and check when do we get px is equal to 0. So let us check for 2 now. What is p2? 2 square minus 2 minus 2. 2 square is 4. So we have 4 minus 2 minus 2, which is equal to 0. 4 minus 2 is 2. 2 minus 2 is 0. So we get p2 as 0. So we can say x minus 2 is a factor of px, because p2 is 0. If pa is 0, x minus a is a factor of px. If p2 is 0, x minus 2 will be a factor of px. So we can say x minus 2 is a factor. So this and this are the two desired factors of this polynomial. So we can write x square minus x minus 2 is equal to x plus 1 into x minus 2. These are the two factors of this polynomial which we have obtained using the factor theorem. So we can factorize an expression using the factor theorem.